The fascinating effect of curves in space-time on us. Did you know that time can pass more slowly in certain places in the universe? And what if I told you that even light can be bent by something invisible, like a whirlpool in space? Imagine living in a universe where the laws of physics can be challenged, and even your own body is being pulled by invisible forces. Let's explore the curves of space-time, which shape everything around us, from the gravity that keeps your feet on the ground to the distant stars. In this video, you will discover 1. How gravity is not a magical force, but a curve that even affects light. 2. Why a minute near a black hole could be an eternity, and what that means for you. What happens when two stars collide and create waves that reach us? And there's more. Are we close to discovering how to travel through time? Don't blink, because the answers are coming, and they could change your view of the universe forever. Stay until the end and get ready for a fascinating journey through the invisible curves that govern everything around us. Are you ready to explore space-time? Let's go. What is space-time? Imagine the universe as a giant trampoline, and all the stars and planets are on it. The trampoline represents the fabric of space-time, a combination of space and time that makes up the field where the entire universe unfolds. When you place something very heavy on it, like a bowling ball, the trampoline sinks, creating a curve. Similarly, massive objects like stars and planets, including our planet Earth, create curves in the space-time around them. This curve is what we call gravity. When you think of the movement of planets, like Earth revolving around the Sun, remember how this curve in space-time affects the planet's orbits. The Sun, being one of the most massive objects in our solar system, creates a very strong curve in space-time, attracting Earth and keeping it in orbit. It's not an invisible force pulling Earth like a magnet, but a curve in the fabric of space-time where Earth is simply following the natural path of this curve, like a ball rolling along a curved track. It's fascinating to realize that the curves of space-time are like invisible folds that alter the movement of the universe. For example, light, which travels in a straight line in flat space, is also influenced by these curves. When light passes near a massive object, like the sun or a distant star, it follows the curvature of space-time and bends from its original path. This phenomenon is called gravitational lensing and can be observed by astronomers when the light from distant objects is distorted as it passes through large masses. Because of these curves, Earth does not follow a straight path in space, but orbits the sun. Gravity is not a force pulling Earth, but the result of the curvature of space-time around the sun. Why is gravity a curve? Have you ever wondered why objects fall to the ground? If you drop an apple, it falls directly to the ground. But why does this happen? It's not because there's an invisible force pulling things toward the center of the Earth, but because Earth itself curves the space-time around it. This creates a sort of invisible slide, a curve in the fabric of space-time, and objects simply follow this curve toward Earth. Imagine space-time as a large, stretched cloth. When you place a heavy object like a bowling ball at the center of the cloth, it curves around the object. Similarly, Earth, with its enormous mass, creates a large curvature in space-time. Everything near Earth, including you and me, follows this curve. This is gravity in action. There's no direct force pulling objects to the ground, but rather a curvature in space-time that directs objects toward Earth's center. This concept of gravity as curvature in space-time was one of the great discoveries of Albert Einstein's general theory of relativity. Instead of seeing gravity as a force acting at a distance, as it was understood by Isaac Newton, Einstein showed us that gravity is the effect of space-time curvature caused by the mass of objects like planets and stars. Space-time is not a flat screen, but something more flexible that curves around massive objects. Planets, moons, and even light, which travel without mass, naturally follow these curves. Moreover, light, which would normally travel in a straight line, can be bent when passing near very heavy objects like a black hole. This means that even light is not immune to these curves in space-time. This distortion of light and objects around massive bodies is called gravitational lensing and has been observed in various astronomical experiments. Light is bent by the curvature of space-time, which can make us see distant objects in ways that they really are not. Even light follows these curves. Yes, light can bend when it passes near something very heavy, like a black hole. This is incredible because light travels in a straight line, but as it passes through these curves, it changes its trajectory. How you are always inside a curve. Right now, you're sitting here, inside a curve in space-time, created by Earth. What does that mean? Well, Earth's presence in space creates a curve in space-time that keeps your feet on the ground, preventing you from floating. If Earth didn't have this curve, we would all be floating in space, like astronauts outside a gravitational field. It's Earth's gravity, or rather the curvature of space-time created by Earth, that keeps you firmly on the ground. Close your eyes for a moment and imagine what it would be like to live in a place where there was no such curvature. Without the curvature, there would be no gravity to keep us anchored to the surface. What would happen if you let go of an object? It would float away, and things like walking, running, and even sleeping would be completely different. Now, think about the effect of a much larger mass, like the Sun. The curvature of space-time is immense, and Earth follows its orbit around the Sun because it is falling into this great curvature. This creates the orbital movement that keeps the planets in their trajectories, and in some way, it is what keeps us alive here on Earth, providing a stable environment for life. Close your eyes and try to imagine what it would be like to live without gravity. Odd, isn't it? This curvature of space-time created by Earth is what keeps us in place, allowing life to exist the way we know it. The clock ticks, differently in curved places. Now, something really amazing that happens due to the curves in space-time is the way time passes. Time is not the same everywhere. Near large masses like black holes, time passes more slowly. This is because gravity, or rather the curvature of space-time, affects not only the space in which things move, but also time. The stronger the curvature, the slower time passes. Imagine you are near a black hole, one of the most massive objects with the most extreme curvature in the universe. 1 minute near a black hole could feel like an eternity to an observer far away. This happens because the curvature of space-time near the black hole is so intense that it distorts the flow of time. For someone far away, time seems to pass normally, but for someone near a black hole, time wraps in a very different way. This phenomenon has fascinating implications and, in a way, may even make us wonder what would happen if we had the ability to travel around massive objects or at high speeds. Time, indeed, can be manipulated by these curvatures, and this opens possibilities for science fiction adventures, such as time travel. If you lived near a black hole, your birthday would take much longer to arrive. This happens because for you, time would pass much more slowly compared to someone in a place with less curvature in space-time. Black holes, the most extreme curves in the universe. Black holes are undoubtedly one of the most mysterious and fascinating phenomena in the universe. They are like whirlpools in space-time, where the curvature is so intense that nothing can escape their pull, not even light. When something very large and dense, like a massive star, collapses, it creates a curvature so extreme in space-time that time and space become virtually inseparable. Once something crosses the event horizon of a black hole, there's no turning back. What happens inside a black hole? No one knows for sure. This is because the curvature of space-time is so intense that it breaks the laws of physics as we know them. At the center of the black hole, space-time becomes so concentrated that it creates a singularity, a point in space where the equations of physics no longer make sense. Could black holes be portals to other places in the universe? Some scientists believe they may be gateways to other dimensions or even other universes, but that's still a big mystery. Gravitational waves, curves that move. When something very large moves in the universe, like two stars colliding, it creates waves in space-time. These waves, called gravitational waves, are like ripples spreading when you throw a stone in a pond. When a star dies in a supernova or two black holes merge, they create disturbances so powerful in space-time that the waves travel through the universe. The most incredible part is that these waves have already been detected here on Earth. Using extremely sensitive instruments like LIGO, Laser Interferometer Gravitational Wave Observatory, scientists have been able to measure these waves, which are smaller than the size of an atom. This allows us to observe events in the universe in ways we never imagined possible. We detected these waves using a device so sensitive it can feel something smaller than the size of an atom. These waves give us a new way to see the universe, revealing cosmic phenomena that were previously hidden. The future, time travel with space-time. If we can bend space-time, could we one day travel through time? Scientists believe this may be possible, but to do this, we would need something very, very heavy, like the mass of a planet or even a star, to create a large enough curve in space-time. Some even suggest that we could use wormholes, which are shortcuts in space-time, to travel to the past or the future. Although time travel is still in the realm of science fiction, the laws of physics don't completely rule it out. In theory, if we can manipulate space-time curvature in a controlled way, we could travel to different moments in the timeline. What would you do if you could go back in time? Would you try to fix a mistake, see the future, or even travel to a historical moment? The future of time travel may be more possible than we think.